Lesson 4.6, Standard Scores and Percentiles. Our objective for this lesson is to be able to find the standard score and the percentile of a data value. Let's define standard score and percentile. First, standard score is the number of standard deviations a data value lies above or below the mean. We often call the standard score the z-score because z is the variable we usually use for standard score. To find the standard score of a data value, we take that data value, subtract the mean, and then divide by the standard deviation. And that'll tell us how many standard deviations we are above or below the mean. A negative standard score means that we're below the mean, and a positive standard score means we're above the mean. Next, percentile. The percentile of a data value is the percentage of all data values in a data set that are less than or equal to that data value. So, for example, when you get your standardized test scores back, like the ACT or the SAT, you'll get a score, and then you'll also be given a percentile. And that percentile means that out of all of the people that took that test, that percentage of people got a score that was less than or equal to yours. For our example, we're told that cholesterol levels for men aged 18 to 24 are normally distributed with a mean of 178 and a standard deviation of 41. And then we're asked what would be the percentile of a 20-year-old man who has a cholesterol level of 190. All right, so notice here that I've included a portion of a table, and I've included the entire table in your notes with relating z-score or standard score to percentile. And that table is directly related to this normal distribution and the 68, 95, 99.7 rule that we talked about in the previous lesson. So for example, we know that 68% of values are within one standard deviation of the mean, which means that if we wanted to know what percentage of values are less than or equal to one standard deviation above the mean, well, we could figure out the percentage that are outside of this range from -1 standard deviation to +1 standard deviation just by subtracting 68% from 100%. That would give us 32%. So 32% are either below here or above here. Well, we just want to know what percent is above here. So that would be half of that, so 16%, which would mean that 84% of all values are less than or equal to one standard deviation above the mean. And if we look onto our table here, we look at our z-score of 1, and we can see that our percentile is going to be right about 84%. So there's a direct correlation between, or a direct relationship between what we saw in this normal distribution and the 68, 95, 99.7 rule and the table that I've given you. All right, so what we need to do first in order to find the percentile is to find the standard score for someone who has a cholesterol level of 190. So what we need to do is take that data value, 190, and subtract the mean, so 178, and then we're going to divide that by the standard deviation of 41. So 190 minus 178 is going to be 12, and 12 divided by 41 is approximately equal to 0.29. So then we can look at, so this is a positive standard score of 0.29. If we look over here, we have a z-score of positive 0.3 is going to give us a percentile of about 61.79. So 0.29 would be a percentile of about 61. So that would be the answer for part A of our example. Part B of our example asks us what cholesterol level corresponds to the 90th percentile, which is the level at which treatment is recommended. So in order to do this, we need to first look on this side of our table and find where we find the 90th percentile. So down here we see 90th percentile, and that corresponds to a z-score of about 1.3. So our z-score is 1.3, meaning that, that we're 1.3 standard deviations above the mean. So let's multiply this by our standard deviation, which is 41. So 1.3 times 4.1 is going to be 53.3. So we're 53.3 points above the mean. And now we can add that to the mean. So 178 is our mean, plus we're 53.3 points above the mean. That's going to be, what, no, 1. 231.3 is going to be the cholesterol level that corresponds to the 90th percentile. And that's the cholesterol level where we're going to want to see a doctor.